Hello my dear friends, in this video we will going to learn the continuity of a topic, that is mechanism of entropy transfer through mass flow. See, we know that the entropy transfer mechanism, there are two mechanisms: heat transfer, already we covered that, and other is mass flow. So in this case, what is that? Since mass contains entropy as well as energy, since if there is a mass, if this is a mass, so this contains energy as well as entropy, right? This contain energy as well as entropy, right? And energy content of a system are proportional to mass, right? That means this mass, if there is a mass, it contains entropy as well as energy, and the entropy and energy of a system proportional to the mass, right? Same, both entropy and energy are carried out. That means, so both energy and entropy, right, are carried out or in of a system by a stream of matter. What is that? That means it said that when there is a stream, so if see that when the mass will flow, so there is must be an open system. So if we take an open system, right, this is your open system, so this is your boundary, of the open system. So this is your control volume, mind it, this is your control volume system. So if there is a mass, let's suppose this is your mass, let's suppose there is a chunk of a mass, this is your mass of m, right? Let's suppose this is your mass m, will into the control volume, this will into the control volume. So this is your mass m, right? That means mass flow rate, energy h, and entropy s, right? This is the entropy of the mass. So this is the entropy of mass m. This is your energy of mass m, and this is your mass flow rate, So if there is a m dot mass will into the control volume, so along with the m dot mass, what is the energy will in? M dot h, and what is the entropy will in? M dot s, where this s is the specific entropy, right? Okay, so since mass contains entropy, as well as energy, and thus mass flow into or out of a system is always accompanied by energy and entropy as well. Energy and entropy transfer, right? So entropy transfer by mass flow. So entropy transfer by mass flow is what? S of mass is equal to m dot into s. M dot s, or this is your m dot s, or m, the mass flow rate by mass flow, right? Okay, hence the entropy of a system increase. So entropy of the system, hence the entropy of the system, that means a control system, is increased by this amount, m dot into s, when the mass is in m amount of the mass, and decrease the same amount of entropy if that same amount of mass will exit from the system, right? So this is your entropy transfer due to mass. So entropy, so there is a two things. Entropy transfer by heat. What is that? Entropy transfer by heat. What is that? That means Qk by Tk. Number second, entropy transfer by mass mission of ms, right? This is your entropy transfer by mass. So this is your entropy transfer, right? That means S in minus S out, right? These two combined will form S in or S out. Number third, what is the entropy change of the system? Entropy change of the system, delta S system, it is what? S2 minus S1. Now entropy change of the system is exactly equal to transfer. Entropy change of the system is exactly equal to the transfer by which mechanism? By reversible phenomena. So next is we will discuss entropy generation. Entropy generation, SGEN, dot or no dot, no. Entropy generation. Okay, so entropy generation. So first, why this will happening, why this will come into picture, why the entropy generation will there? Because irreversibility such as, due to irreversibility, this is due to irreversibility, and that irreversibility is such as caused by friction, mixing, That's when two gas are mixed together, chemical reaction, heat transfer through a finite temperature difference, not infinite. If heat transfer through, what is the heat transfer through a finite? Heat transfer through a finite temperature difference is the irreversible process, or heat transfer through infinite temperature difference is a reversible process. So when there is a irreversibility, that means heat transfer through a finite temperature difference, and unstrained expansion, that means expansion against vacuum, non-quasi-equilibrium process always cause entropy of the system to be increased. These all cause that entropy of the system will increase, and entropy generation is the measure of entropy created by such effect during the process. And if the so the friction, unstrained expansion, like that, this always cause that the entropy of the system will increase. And how much entropy will increase due to such type of effect, due to such effect, that will measured by the entropy generation. So this is the measurable parameter. Entropy generation is the measurable parameter. So why the entropy generation will come into picture? Why? Because we measure the what is the entropy change of the system, and entropy change of the system due to irreversibility is caused by friction, unstrained expansion, mixing of a gas, chemical reaction, heat transfer through a finite temperature difference, right? These are all created by the entropy. This all are the responsible to increase the entropy of the system. And when we are measuring how much it will increase the entropy due to such type of effects, that measurable parameter is denoted by entropy generation. So entropy generation is a measure of, so what is that? This is measure of the entropy, created by irreversibility during a process, right? Number first. So what is that? We know that what is the entropy balance? Entropy balance, what is that? S in minus S out is plus S generation is equal to delta S of the system, right? If the process is free from all irreversibility effect, if you think like that, there is no any practical situation, but in ideal case, if you think that there is no any irreversibility within the system, that means it is free from the friction, all the things, so the measurable parameter is 0, so we can not any entropy generation, there is no any entropy generation. So what is that? So this is for ideal process, that means a reversible process, right? So what is that? So this is what? Delta S of the system is what? S in minus S out. That means it is exactly equal to the transfer function. That means entropy change of the system is equal to entropy transfer. So that means entropy change of the system, is equal to the entropy transfer. Entropy transfer, right, is equal to the entropy transfer. So it is analogous of the energy conservation. See the beauty. So there is one point is not that. So in this case, entropy balance relation, in which process? In the reversible process. In the reversible process, becomes analogous to the energy balance. So what is the energy balance? What is the energy balance? Delta E of system is equal to what? Energy in minus energy out. This is your energy balance. So, but what is the difference is that this energy balance is for any system, sorry, any process, for any process. But this entropy balance is only for the reversible process. This is the beauty. Right? So there one point, note that this is the very, very beautiful utilization of the second law. So energy change of a system, equal to the energy transfer for any process, but the entropy change of a system equal to the entropy transfer only for a reversible process. So when there is a process reversible, the conservation of energy will exactly apply to the conservation of entropy. So entropy will conserve if there is a process is reversible. But in the all practical scenario, the process is irreversible process. That means reversibility is the very limiting case of any process. So in actual practice, entropy, there is no any things about the entropy conservation, but energy will conserve for any process, either reversible or irreversible process. So the analogous of energy conservation is like entropy balance. Energy balance is equivalent to the entropy balance. If you say that energy balance is equivalent to the entropy balance if and only if the process is reversible. Okay, now next we will see that second point is what? See, the entropy transfer by heat is zero. For adiabatic system, we know that entropy transfer, that means entropy will transfer, that means Si minus So is 0 for which? Adiabatic system. That means entropy transfer by heat. This is for what? This is for heat and mass. So if there is a mass is 0, let's suppose, that means closed system. So if there is a adiabatic, so entropy transfer is 0, and the entropy transfer by mass is 0 for closed system. So for closed and adiabatic system, so for closed and adiabatic system, entropy transfer is 0, right? There is no any entropy transfer. Number third point is that, see, we know that S in minus S out entropy balance plus S generation is equal to delta S of the system, right? This is what? This is your kilojoule per Kelvin. So, but for at rate form, what is the rate form? Divide time, that means S in dot minus S out dot plus S dot is equal to what? Delta S of the system by dt. No problem, this is your kilowatt per Kelvin. Okay, so what is that? If there is a system, any system, if take is a system, right? If this is a system, right? This is your delta S of system. So there is a S generation is greater than equal to 0. Now, if there is a mass in, mass, and there is a energy, heat, there is a mass out, and there is a heat out. So these two is responsible for S in, and these two responsible for S out. Yeah, either one, no problem. So we see that entropy generation is due to irreversibility, or irreversibility caused by dissipative effect, that means friction like that, and these are the internal phenomena. So S generation, entropy generation is the entropy generation within the system body, within the system boundary only. This is within the system boundary. This is no any there is no any something like that. This is external to the system. Entropy generation is always within the system, that means within the system. Hence a process for which, so if there is a process, so a process for which कोई आपने प्रोसेस माना फॉर विच एस जनरेशन इज जीरो, what is the comment? S generation, what is your comment? S generation is zero. So what is your, so you can say that there is a reversible? No, it is internally reversible. Why? Because it is within the system. Within the system. So is internally reversible. It need not be externally reversible, but not necessary. Not necessary that totally reversible. Totally reversible. Totally reversible means external plus internal plus internal plus external. It is not necessary that totally reversible, because reversible is two things. It is internally reversible or either totally reversible. So energy generation is the something related to the internal irreversibility. Internal reversibility. So see, we already discussed repeating and repeating for these things, but you may think about that. Reversible. The reversible is two, either internal reversible or either totally reversible, right? If there is an internal reversible, then S generation is zero, because it is within the system boundary. But the totally reversible, that means it is reversible internally as well as externally. So entropy generation is zero. It's not necessary that it is totally reversible. It is internally reversible only. That means external it may be, external it may be irreversible. So what we can say, what I am saying, that means, hence that means the totally entropy generated during the process can be, so if we find that the totally if we find that, what is that? That means there is a question mark is here, that the total entropy generation. What is the total entropy generation? What is the total entropy generation? This generation can be apply a concept of entropy balance. Entropy balance to an extended system. So here the external, that means immediate external. External, that means surrounding node. If you think about entropy generation, total entropy generation. What is the total entropy generation? That means entropy generation with internal plus external as well as. So in this case, we assume a system as an extended system, and extended system include system plus immediate surrounding. Right? So if you balance the entropy, that means entropy of the extended system, that means entropy generation. That means if you think about the S gen total, so you find S generation of system plus is generation of immediate surrounding. So if you think like that, we can, so entropy generation of a system, it is okay, but how can you calculate entropy generation by immediate surrounding, and what is meant by immediate surrounding, we will discuss in the next video lecture. So up to that there is a, okay, thank you very much.